Afternoon, everyone, and welcome to Red Wunz Go Fasta. First, a little bit, who am I? My name's TerMarsch. I live over on Vancouver Island, up in British Columbia. And although it shares the same name, don't mistake it with Vancouver. From Vancouver to where I live on Vancouver Island is approximately 4.5 to 5 hours each direction. I can be found as TerMarsch on CPAN. I've been a Perl developer since approximately the mid-90s. I worked with ActiveState and Sophos through 98 to 2006, roughly. But as a career consultant and a career contractor, much of my time has been spent working on darkpan projects. Not even in the sense of code that hasn't hit CPAN, but contractually I'm not even allowed to say who I worked for, much less what we did, which kind of sucks. But to date, I'm here with ZipRecruiter, and I suppose I'm somewhat obligated to say, yes, we're also hiring, along with everyone else. A disclaimer, the opinions and things we're going to discuss here today are my own. They're not necessarily the opinion of the company. And we've all heard the phrase, there's lies, there's damned lies, and there's benchmarks. And today I'm going to go through a whole bunch of benchmarks. But I'm specifically looking, for my purposes, going down these rat holes at comparative results. So when we're comparing various JSON parsers against one another, I'm simply looking to see which one is faster. It's not a matter of absolute values, and numbers from one performance run are not immediately comparable to those from another. I'm using benchmark PM for doing my timing, running thousands of iterations, chucking out the top and bottom 5% as outliers, and taking a mean average of the remaining set. It's not foolproof. I would not say that it's statistically significant, but I'm also not looking for perfect results. And I guess also starts with the question of, really? Do red ones go faster? Well, there's Lightning McQueen. He's red, and he's really fast. There's the Doppler Effect, where objects do appear red-shifted if they're moving away from you at high speed. However, that happens to be a significant fraction of the speed of light. But it's red, so for my purposes, we're going to say that one goes faster too. And we also get SpaceOrcs from Warhammer. Fantastic race. It's a species that can make any of their vehicles go faster just by putting red paint on them. However, SpaceOrcs also believed that racing stripes make everything go faster, and if it didn't work the first time, you just use bigger nails. But today, I'm here to talk about some adventures in JSON and JSON benchmarking and profiling. It began back in early mid-2016, where we had an internal contest at ZipRecruiter. And the goal was we were looking to test out new frameworks for internal microservices, and it was an opportunity for each team working in their particular language or their particular tool set to show off their chops and try something new. Round one, the requirements were pretty simple. We're going to parse some JSON data from a series of data files that are representative of what we're using in production, and we're going to stuff that into a template and spit it back out to a browser. Really simple. My contest entry was codenamed Seawitch, based it on Kelp, TextXslate, Gazelle, and JSON Access. Kelp is a Plaque framework. Would consider it a micro framework. It's pretty low level. We had considered simply writing it in pure Plaque, but by the time we add in all the extra pieces that we'd want to have to make it easier to use, by that point we've already written much of Kelp. TextXslate was almost a no-brainer for us. We're already using Template Toolkit internally, so TextXslate allowed us to improve the performance of that with Access. And obviously JSON Access is sort of the de facto go-to for JSON parsing in Perl. How fast was it? On an AWS C3 4x large, compiling Perl 524 with Perl Brew, we could get it down to an average latency of approximately 1.3 milliseconds per request at 5,800 requests per second, which I thought was pretty good. It was not too shabby. But where was that time being spent? So I went back, as we would normally do, fired up Devel NYT Prof, and was surprised to see that JSON access comprised a significant portion of my time. Also not too surprising, because, gee, we're not doing a lot on this application. We're parsing JSON and spitting it out in a template. And guess what? Those are the top two things. But if I'm spending all this time parsing JSON, maybe I could find a faster JSON parser? Maybe? So I went and did some Googling, as we all would, and found that there were a number of other people out there who had already benchmarked dozens and dozens and dozens of JSON parsers. Milo Yip has his benchmark where he evaluates 40-plus open source C and C++ JSON parsers and displays them in his little fabulous graph showing that, oh, big surprise, his is the fastest. Go figure. I also found Lev Walken, whose numbers and results were a little older. They were a couple of years back, but it provided some extra comparison points for me, as well as Kostya, who compared not just C and C++ parsers, but also pulled in Python, Rust, Java, D, JavaScript. So it gave us, again, gave me a broader selection of JSON parsers to look at and consider. But lots of the ones I was just looking at are in C and C++, and I'm writing Perl code. And so, XS. I'm sure that most of us here would know that XS code is basically kind of glue code to help us bind C and C++ to Perl, at least particularly for my needs at this point. And it's what makes JSON XS go so fast. It also happened to be stuck in my head at the time because just weeks prior to that, David Farrell had just blogged about writing URI encode XS, where for his URI encoding, he was seeing a 55 times speed up as compared to pure Perl. So it seemed promising. And off I went to go make some XS bindings for some JSON parsers. So I picked one. It's UDP, has a JSON parser, very low footprint JSON parser written in portable ANSI. It's DOM-based, relatively simple, put together some really quick and dirty JSON bindings, fired it up in my benchmark and compared it against JSON XS, and I'm nowhere close. Absolutely nowhere close. So why? Based on all the results I saw from everybody else doing this JSON benchmarking, the UDP should be way faster than what I'm doing in Perl. So JSON XS is really fast. Why? And so I sat down and went back through to see what was Mark Lehman using and doing in JSON XS that perhaps I missed in my XS bindings. Maybe there's some secret sauce in there that I can find to help boost the speed of what I was doing. And this was my first pass at making JSON bindings, XS bindings for this JSON library, so there's probably a whole bunch of stuff I missed. I found that one piece he was doing is he pre-allocates his AVs. And we're back.
We need a few of your slides.
That's okay. I can send you slides. He pre-allocates his AVs. So when you know how big your array is going to be, you can extend it at the beginning, and then you can add all your values to it. And it saves Perl from having to grow and copy all the elements over into your brand new array as it grows it. And of course, the more items you have to put in your array, the bigger it has to grow, the more times Perl's going to have to regrow it and recopy it. Similarly, you can pre-extend your hashes. Now, because I'm using a DOM-based parser, I get back a structure that tells me, oh, it's a hash, it's got 6 keys, and here they are. So I already know how many elements I have to work with. And so similarly, I can use HVK split initially to pre-extend my hash keys, and it avoids later splits of the buckets further on as we start to add items. And again, having more items to put in will save you progressively more time. I also found that he's fast pathing his simple ASCII hash keys, which I thought was kind of interesting, unique. And for the data set I was working with, it also looked really good because many of the hash keys in my data, they're short, they're small, and they're ASCII. There's no UTF-8 or minimal UTF-8 in my hash keys. So Schmork was fast pathing those and would call hvstore directly. And for either longer strings or anything where he detected that he had UTF-8, he would call hvstore entity. It was a little surprising. And similarly, he would also fast path his numeric conversions. Again, if I'm dealing with small numbers, it's pretty easy to figure that out on your own and parse it, as opposed to having to call grok number. And so I went back, took my access bindings, applied some of these tricks to them. It's like, okay, I feel like I've got another pass at this. Maybe this is going to be better. And no. Well, yeah, it's a little better. I'm like a 3% improvement, which at this point I would simply consider margin of error. Not a significant improvement, and was really disappointing.
Is that with all of those?
With all of those, it still didn't give me anything significant. So I was disappointed. But hey, like when I went looking at those benchmarks, there were tons of other JSON parsers to play with. So let's try a few more. So I found Rapid JSON because, gee, when Milo Yip had it, his was by far the fastest. The only thing he claimed that was faster than his was stirdup. And so I sat down to have a look at that. He writes it as, it's a fast JSON parser and generator for C++ with both a SAX and a DOM-style API. And Rapid JSON is actually kind of unique in that it's not just written in C++, it's completely written in C++ templates. So, yes, C++ templates. And it's definitely cool and interesting. You kind of have to wrap your head around it, but is by far the most interesting use of templates I've seen. It also parses the string in situ, so it modifies the original string. As he's parsing it, rather than copying the string piece by piece, he simply takes the long string that you gave him and he just drops nulls in as he goes, and then hands you back a structure with pointers into that really long string that you originally handed him. And so, again, whipped up some really simple access bindings to this, fired it up, and I'm closer, but I'm still not there. And considering that, in Milo Yip's benchmarks, he's like the fastest bar none, I'm really starting to question what I'm missing and what I'm doing wrong. Well, let's try another one. There were more on the list. So I take Jasmine, is a world fastest JSON parser tokenizer. Again, DOM, not SAX, but Jasmine was a little interesting in that it requires you to pre-allocate a stack before you do the parsing so that it has somewhere to drop all the tokens in. It won't do the memory allocation for you, which was a little different than many of the other APIs that I'd seen. And if you have a large enough JSON file to parse that you actually didn't give it a big enough stack, it returns you an error code and says, you need a bigger stack, allocate a bigger stack, try it again. And so, again, whipped up some access bindings, ran it through the same benchmarks again, and I'm still really disappointed in the results. And now I'm wondering, why am I doing this? Because I'm probably 2 weeks in just writing access bindings and running benchmarks, and I'm questioning, was this even a good idea at all? Because I'm no closer. So I want to dig a bit deeper. Normally, if I was writing Perl code, I'd fire it up under NYT prof and figure out, where's the time being spent, and I'd try and zero in on that. But this is access code. I'm not spending time in Perl. I'm spending time down in access and down in C land. So I need some code profilers. And there's quite a few out there. This is only a small set to choose from. There's gprof and gcov, valgrind, oprofile, perf. Let's try some of them out. Gcov and gprof are mentioned in the Perl Hack Tips man page. I couldn't get them to do a thing for me. So I tried valgrind, which I know is fabulous for chasing down memory leaks, and callgrind extends that with call patterns. And you can use kcache grind for visualization, and it's really beautiful and super powerful. Oh my goodness, is it slow? It's like 50 times slower. And I'm trying to get a relatively rapid turnaround on. I'm going to make a minor tweak. I'm going to run it again, and I'd like to see some results. And although these are fantastic tools, they're not giving me the sense of being able to iterate over my ideas fast enough. And so I tried oprofile. It's a system profiler for Linux. It's a little unique in that you can not only do application profiling, you can also rig it up to do system profiling. So you can profile everything running on your system at once. But because it's really powerful like that and has all these deep hooks into the kernel, if you don't run it right, you can also hang your machine many times. And that's now also frustrating because I'm still not able to iterate over this as fast as I'd like. It does give you some really good results, though. Using Perl Brew, I'd fire up my test, get it to dump, the symbols, where was the time spent, and obviously it gives us, gives me the data I would want, but having it in a different format would be useful. The data's here, but it's hard to read. And having a visualization of the call graph would also be helpful. So we'll try another one. I'll try Perf. I'm already a couple weeks in. What's one more? So I found Perf is Linux kernel profiling, flame graph. I'm sure many of you have already seen a flame graph. If you've used NYT-Prof, they put them at the top. But to do this, you actually need to have a copy of Perl that's built with debugging enabled. So when I use Perl Brew, I'm just going to use my -d debugging, give it -g for that because I actually want to get dwarf output. And so I can then fire it up. So I'm going to run Perl Brew, tell it which version of Perl, perf record, give me a call graph of everything that's going on in dwarf, 2,500 samples per second, and here's the command line I want to execute. I can then process that, collapse it all, turn it into a flame graph, I get this beautiful SVG, and it tells me some really cool things. It's like, wow, now I can actually see where is the time being spent. I get this sense of how much time is in Perl, how much is in Rapid JSON, how much is in my XS bindings. This is exactly the type of visualization I'm looking for, where I can drill down and see what's going on. And I will wait. Nope, that's good. But
Why did you start with that?
well, yes, why didn't I start with that? Originally, I started with the Perl Hack Tips man page, figuring, hey, if someone's going to tell me how to profile access code, maybe it's in the Perl man pages. Unfortunately, that wasn't the answer that I found.
This talk wouldn't be long enough.
No, the talk would not be long enough. I would not be deep enough down this rat hole. But then along comes Max, one of the guys at work, and he's like, hey, Graham, I saw this post on Hacker News the other day, and this guy claims I dropped his JSON parser into my benchmarking harness, and it was twice as fast as both Rapid JSON and SA-JSON. And I'm like, oh, Max, like, I'm weeks into this. This is crazy. And so I'm looking at what this guy has, and I'm looking at his results, and have really high hopes. The short lines in the middle are Rapid JSON, which I had previously seen as being really fast. So both SA-JSON and PJSON look really promising. Maybe I should go try those too. And so back we go, write some more XS bindings. So we'll try SA-JSON. A lightweight, extremely high performance JSON parser for C++11. Again, DOM, not SAX. And in situ parsing, so it's still continuing to just parse it without having to copy it. But it did have trouble parsing one of the JSON files I was working with. And admittedly, I have yet to go back and determine why. I simply pushed that file aside and went, great, I will continue to do my comparisons between JSON XS and SA.json with just these remaining data files. Fire it up, run another set of benchmarks, and I'm closer, but I'm still not there. Well, maybe we'll try Purple JSON, or PJSON. It's written by Rich Geldrick. And in fact, he doesn't even make it available on GitHub. He simply dropped it in a paste bin. Thanks, dude. Super fast JSON parser with an ensemble-style DOM. Again, DOM, not SAX. But he specifically coded his to try and take advantage of superscalar processors. He's pre-rigging it, expecting that you're probably running on Intel, and you've probably got things so that if I can line up all these registers correctly, then I can get the processor to execute 3 or 4 of them in the same clock cycle. Seemed really promising. Sounds like a great idea. How does it do? Close, but no cigar. So, thanks, Max. That's a whole other week of work. But hang on. I've been looking at these and talking about, some of them are DOM and some of them are SAX, and most of the ones I've been using and created access bindings for have been DOM-based parsers. Rapid JSON had a SAX parser. And in Milo Yip's benchmarks, his SAX parser is faster than his DOM parser, because his DOM parser actually uses his SAX parser to then build the DOM and hand it back to you. So maybe I should go try the SAX parser, see how that turns out. Build a whole new set of bindings, do it all over again, wash, rinse, repeat, and lo and behold, I'm now 3-4 weeks in, I can finally match the speed of JSON XS. Yay! But there was also something else. Like when I went back and looked at Chad Austin's benchmarks, he said that SA.json and PJSON were like way faster than Rapid JSON, but I'm not getting this result at all. Not at all. Why? I still wanted to answer this question. So I went back and had a look at some of his other graphs where he would show that Rapid JSON performs really bad against these other JSON parsers. And then I noticed something interesting and thought about it and was like, wow, hang on. In this particular set of benchmarks, Rapid JSON performs poorly against MS Visual C 14, but Rapid JSON is completely built out of C++ templates. And in fact, is the only parser I've used built out of C++ templates. And MSVC doesn't do that really well. That's why the performance sucks. But then I went and looked at some of his other graphs where he's running it on Ubuntu, so he's using GCC and CLang. And again, found that, although the performance for many of them is similar, the yellow line on the graph always sucks really bad, which is Rapid JSON, but that's Rapid JSON with CLang, which again, for the version that he's using, happens to have poor support for C++ templates. I was like, wow, okay, I've been a developer for how many years and have been using Perl and had completely forgotten that choosing the right compiler makes a world of difference. So I decided I'd go back and take a look at the profile data once more. So this is a different run of Rapid JSON, but as I was looking at it and trying to figure out, where's my time being spent, I noticed that it's actually not a matter of how fast we can parse the JSON. The JSON parsing is really fast. What it turns out to be the big time suck, it's how fast can we take that and turn them back into Perl variables, which was an interesting light bulb moment to have, because it then sends me down this whole other rat hole of like, wow, can we make Perl go faster? Maybe there's other things I could do to make Perl go. And so I sat down, let's try the simple options. Let's just compile it with native optimizations. Maybe that'll make a little bit of a difference and at least show me some bit of an uptick on the graph. And when I run them through with rapid JSON, because it's the one that's performed the best, I see that, using the regular O2 that you get with Perl Brew compared to MArc native on my particular machine didn't really make much difference. In fact, MArc native performed not as good as O2, which is a little disappointing, but at the same time, it's also close enough that I'm considering it margin of error. Maybe use my malloc, which gave some surprising results. You can compile Perl with use my malloc, so it's using a Perl malloc, not your system malloc, and that seemed notably faster across the board, which was cool. Maybe I'll try the two of them together. What if I use my malloc and I'll use native compilation? It's kind of a wash. Again, it does not perform as good as just O2 and use my malloc. So I thought I could finally declare a winner. Yeah, I finally figured a way we can get Perl to go faster. I've got a JSON parser that's a little bit faster than JSON Access. And it gives me approximately a 5 to 9% win over JSON Access in parsing. In my opinion, take that with a large block of salt, between 5%, 7%, for me, that's close enough to be considered margin of error. Again, at the beginning, I'm not looking for perfect results. I'm looking for sort of trends. I know that my methodology is somewhat flawed. So 5%, I'd consider a wash. Thus, it didn't seem to be worth spending any more time on fleshing out or spending more effort on doing rapid JSON bindings. But then I got kind of suckered and volunteered into doing this as a talk for the Perl conference. It was like, hey, I should go back and rerun those numbers because that was a year ago. So I said, okay, when I ran these benchmarks the first time in May 2017, I was running them on an i7 7700K, Fedora 24. I'm still using Perl 524 from Perl Brew, glib C223, and GCC 6. So that's what I had then. But, I've upgraded my desktop. What do I have now? It's the same hardware, but I'm running it on not Fedora 24, but 27. Slightly different version of Perl. It's not 24.1, it's 24.4. But glibc has been updated in this version of Fedora, which includes a per-thread malloc cache, which, nobody's really said how much faster it's going to be. It's dependent on your workload, but early claims hoped that for small string allocations, it would be notably faster. I'm also using a newer version of GCC, which includes a number of performance opts over GCC 6. And of course, we've all passed, the earlier this year, so there's all the spectrum mitigations in place as well, both in the kernel and in GCC. So I was like, oh, okay, I basically just updated my system, rerun my benchmarks. How does it look? And it turns out that most things got slower. But SA-JSON and JSON Purple got slightly faster. Again, though, we're sort of within margin of error. Looking at the numbers, we're off 5-7% for most things. I'd consider it a wash. Well, okay, if I was 524, I know that when I ran the benchmarks originally, right after that, 526 was released. So what if I took all the tooling I've used and tried a newer version of Perl? And while I'm at it, if I'm going to go to the trouble of trying a newer version of Perl and try 526, I might as well try bleed Perl, because, I'm just going to add some more things into my test array, fire it up and run it again. Because although 526 contains some improvements in the hashing functions that are used to create your hash keys, 528 includes a whole ton of performance improvements, including faster string manipulation. And what am I doing? I'm flinging around tons of strings all the time. So we'll run it through, and what do I find out? 524 to 526 is kind of a wash. Bleed, however, takes about a 10% boost and goes notably faster. And now at approximately 10%, I'm interested. So what if we optimize bleed? We already did this before. I tried it with the other ones, with MArc native. So we'll try bleed, and we'll try bleed with O3. It gets a little bit better. And then, gee, what if I use my malloc, because that was promising previously? I can run that through, and was incredibly surprised at the results. Because although previously I had looked at it and found that it made an improvement, I'm now looking at a significant improvement. JSON purple, we go from approximately 600 to approximately 800. That's almost a 1/3 boost. So what if I optimize it? I get a little from O3, I got a huge chunk from use my malloc, and again, see that it gets even faster. Except for JSON parser access, which was the very first one I tried and apparently sucks really, really bad. Yay! Finally, I have something that looks really promising and looks like a win. So I wanted to say, okay, let's do one last comparison here. What if I go back and take a look at what did I have last year and what's the best I can do this year? So if I compare my original May results to an optimized bleed, where JSON access could give me roughly 540 iterations previously, we can now get 670, which is cool. But best of all, I can get JSON purple, where it could almost match it before. It's now way out in the front at over 850 iterations. And again, these numbers are basically comparative. Outside of that graph, the numbers are useless, because I'm not looking at an absolute value. But it led me to conclude completely different results. Because previously, I'd found that at a 5 to 7%, it's not worth spending the effort on my continuing to go down this rat hole. But now looking at, I can go 20, 25%, 30% faster. This is now worth my spending some time to look into it. I'm getting approximately a 25% speed boost from using bleed over 524, and from compiling it with O3 and use my malloc, and from having my system libraries updated. I'm also getting another 25% speed boost from using JSON purple in that environment as opposed to JSON access for the same data files. Now, admittedly, it's bleed. It's going to be several years before many of us can even use that in production, but looking ahead, it was super promising. When 528 finally gets here, it's going to be awesome. And it also led me to sort of reaffirm that if you have the option in your production or even your development environments, if you can compile your own Perl and use Perl Brew, it's worth it. Perl Brew makes this super easy to do. But it also reminded me of the things I had forgotten from years past, that when performance is key, every single optimization counts. And it's not just, can I make my Perl faster and can I make my Perl more efficient? It came down to, I'd forgotten about, choice of compiler makes a difference. I was compiling stuff in the 80s and the early 90s, whether you used Semantic or Borland or IBM, made a huge difference. We don't have the same selection of compilers anymore. Particularly on Linux, you get your default install, you get GCC. That's kind of the de facto. But going through this process reminded me that your choice of compiler matters. What version of your system libraries you have installed matters. And which memory allocator you're using makes a substantial difference. My action item, I need to go back and finish this, because now that I've seen that I can get this speed boost, I need to take JSON purple and actually get it up to speed, do some more exhaustive testing, implement the JSON encoding so that I can do both halves of not only parsing it but encoding it, and I need to get that released out to CPAN. So I'm taking that as my action item from the conference. I'd like to give lots of thanks. I'd like to thank ZipRecruiter for giving me the time to do this work, Max for throwing me over the deep end with, oh, there's one more JSON parser you should go test, Jeff for laughing when I screamed because I've been like way too far down this rat hole, TPC for accepting the talk, and I'd like to thank all of you for joining me here today. Thank you. Questions?
I've got the dumb question that's probably going to get me kicked out.
There's no dumb question.
I upset the wrong people.
Fair enough.
What about the JSON replacement put out by Grinny?
I'm sorry, which JSON replacement?
cPanel JSON XS.
The cPanel version, I had previously seen that the cPanel version did not have a notably different performance than simply JSON XS. But we'll also admit that no, I did not compare those in this process.
Yeah, Grinny will make his claims about changes that or improvements he's continuing to make.
Okay. Then perhaps it would be worth my going back and taking another pass.
Yeah, I've been using JSON XS on a couple of projects, and word came down to me that, no, use this. The benchmark shows faster. Being too lazy to run it myself, I took my boss's word.
Fair enough. Other questions? No? Oh,
Did you ever figure out why JSON XS was so fast to start with?
it's really well done. JSON's actually kind of unique in that when you parse JSON, you only ever need a single character peek ahead. So you can parse the whole thing simply looking one character ahead, one character ahead. And being that the majority of the time is actually spent not parsing the JSON, but turning it into Perl objects and Perl structs, his JSON parser is really efficient. And admittedly, he's making lots of these cute little cheats. If we know that it's ASCII, that's great, we can fast path it. Any other questions?
Yeah. What exactly is use my malloc?
Use my malloc.
What is that doing that's so much better?
It's using a Perl malloc as opposed to your system malloc.
Yeah. Why is it? Do you know why it's better?
I do not know why that one is substantially better. I know that depending on what system you're using, your system memory allocator, some of them are great, some of them are optimized for different types of workloads. But I suspect that because the Perl one is obviously written and shipped with Perl, that it's tailored to the types of memory management that Perl wants to do.
Did you find that in docs somewhere? What led you to try it?
I knew the option existed because I'd previously seen the option in the documentation, and in many ways was throwing darts at the wall. It's like, okay, let's try this one. We'll try this option. We'll try this option. And admittedly was surprised to find out how much of a difference it made. Great. Thank you.